This is lecture number 2 for chapter 1. We're going to actually finish the packet for chapter 1 today. Then there is a short video on mass versus weight, and that will be it. And then we'll discuss the assignments that will be due in class. So let's rock and roll. So we're on the back of the first page of the chapter 1 notes, and before we finish with the CFC story, we have to get a few terms down. So we talked about matter. Matter is anything that has mass and takes up volume. When we talk about mass, we're talking about the amount of matter an object contains. When we talk about volume, we talk about the amount of space an object occupies. So air is matter. It has mass and it occupies volume. If you took an empty balloon and weighed it, and then blew into the balloon and filled it up with air and tied the end, and weighed it again, it would weigh more. The difference between mass and weight is that weight is the amount of matter and the pull of gravity on that matter. So the moon is 1/6 the size of the Earth, so your weight is 1/6 your weight on the Earth. So if you weigh 180 pounds on the Earth, you would only weigh 30 pounds on the moon. Your mass doesn't change, but your weight will. So weight is dependent on gravity. During this course, we're going to be discussing matter macroscopically, what we can see, microscopically, which is small enough that you need a microscope to see, and submicroscopically, which is pretty much the theoretical part for us because we cannot see it, which is atoms, molecules, and atoms broken up into protons, neutrons, and electrons. So since we really can't see it, we try to have a way of visualizing it. And we visualize with models. A model is a visual or a verbal or a mathematical explanation of the data we collect. A graph is a model. It helps us to visualize things that are hard to grasp. We also need to understand the scientific method, which I'm sure you've seen in all of your other science courses. The scientific method usually starts with an observation. An observation can be qualitative. In other words, it relates to the 5 senses. Or it can be quantitative, which means it involves a number. The only way you can get a number is if you use an instrument. So if I were to say the mass of a book is 200 grams, that is a quantitative observation. If I were to say the book has an orange and black cover, that is a qualitative observation. Observations lead to guesses. A guess is simply a hypothesis. It's a tentative statement or prediction about what has been observed. It is a guess. A hypothesis may be true, it may be false. So we perform experiments. Experiments is a set of controlled observations that test the hypothesis we came up with. The independent variable is the variable that is changed. We plot it on the x-axis, and usually it's something along the lines of temperature. We change the temperature and we see how something reacts to that. The thing that reacts is the dependent variable. It changes in response to a change in the independent variable. And then we have what's called a control. A control is something that essentially stayed the same before and after, and it is a standard that we use for comparison. Based on our experiments, we can draw a conclusion. A conclusion is simply a judgment based on the information obtained. We develop laws, which is a relationship that stays true through many experiments. And then eventually we come up with a theory to explain what happened during the course of the experiment that then ties in with many observations and investigations over time, like the atomic theory, the theory of the atom. So if we now go back to our story of the ozone hole and chlorofluorocarbons, in the 1970s, two scientists, Molina and Rowland, hypothesized that CFCs, the chlorofluorocarbons, broke down atmospheric ozone. So that's a hypothesis. Scientists around the world collected data and found that not only are CFCs increasing, but also other compounds like carbon tetrachloride, CCl4, methylchloroform, 1,1,1-trichloroethane, CH3, Cl3, and at some point we're going to draw these molecules. So it would look like this. There's 3 chlorines on a carbon, and on another carbon we have 3 H's, but that's later in the year. This led to the Montreal Protocol that in 1987 countries agreed to phase out these compounds. So it was the scientific method in action, and it was pretty impressive that the world could come together to work and try and solve this problem. However, the ozone layer is not expected to start recovering from the depletion until 2060, so another at least 40 years. And now a quick video on mass versus weight.
This brings us to an often confused concept of measurement. The terms weight and mass are often thought of as the same thing. People use the two terms to mean the same thing. This is a grave mistake, because weight and mass actually measure two different things. Weight is the amount of gravitational pull on an object. The weight of an object is a determination of how strongly gravity is pulling down on that object. We usually measure weight with a spring scale. A spring inside the scale is stretched by the pull of gravity on the object. But strength of gravity changes from place to place. For instance, a person who weighs 60 kilograms on Earth would only weigh 10 kilograms on the Moon. The Moon is about 1/6 the size of the Earth, and it therefore has much less gravity. That's why this lunar rover is bouncing around so much on the Moon, where everything would weigh less. However, the mass of an object isn't affected by changes in gravity. That's because the mass of an object is a measure of the amount of matter in an object. If we take the balance scale to the Moon, the weights are affected as much as the object being massed, so the reading is the same as on Earth. For most situations on Earth, mass and weight will appear the same, but it is important to know that they are really measuring different things.
And that's it for tonight. There are no assignments that you have to do yet. We'll discuss that in class, so enjoy the evening, and we will see you tomorrow.